Hello and welcome to practice number 9 of Circuit Lab, multiple sources, special notation, and resistor identification and marking. My name is Mr. Burleson, and you can reach me at geaux15@hotmail.com. So, last class we talked about how a motor works and how a DC motor has usually 2 or 3 windings but 2 permanent magnets, and then they use the commutator and the brushes to alternate the current on the windings on the armature, which is part of the rotor. And what that does is that it changes it from north and south pole so that the motor is both pushing and pulling as it goes around, as shown in the diagram to the right. The parts of the motor, please know what the brush is, the commutator, the armature, the north and south pole permanent magnets, the stators, the rotor, how the terminals work, and it's really important that you understand why they're wired the way they are. The other thing to keep in mind is that as you look at the current remains the same. It's just that the internal windings, it changes the direction on the internal windings. But let's talk about multiple sources. Sometimes a circuit has more than one source. So generally speaking, if you want to add two sources, if they're voltage sources, they add really well in series. Current sources add really well in parallel. Okay, so if you look below, you can see how V1 and V2 are added together since they're in series. So the equivalent voltage source would be V1 plus V2, and the same thing for the two current sources, I1 and I2. Since they're in parallel, you can add them together. However, you should not put voltage sources in parallel or current sources in series, because if you do those things, it will violate the circuit rules, which means that it's not a valid problem. Also, keep in mind, circuit symbols, we've sort of gone with sort of the standard circuit symbols, but there are hundreds of circuit symbols. So you should have a couple of pages of just nothing but different circuits symbols. Keep in mind, sometimes they also just draw a picture of, like, if you wanted to have a light bulb, you can either use a light bulb symbol, you can put a box and write light bulb in it, you can put a picture of a light bulb. They use a lot of different things for things like light bulbs. Certain things like open switches and closed switches are very similar, but like the circle with an X is a lamp, or a circle with a semicircle in it, as shown below, is also a lamp. Okay, these are very, very common ways to see. The other thing to keep in mind is that anything that's got an arrow through it is like a variable resistor, a variable capacitor, etc. But one of the things to keep in mind is that another common hands-on activity is to give you resistors and then have you look at the resistors and be able to tell what they are by their color-coded markings. Okay, generally there are 4 markings on a resistor: A, B, C, D. Okay, so A is the first significant digit of the component, B is the second significant digit, C is the decimal multiplier, and D, if it's present, it's not always present, indicates the tolerance. Okay, now if it's only a 3-colored resistor, what that means is that there's no tolerance marking, which means it's plus or minus 20%. Okay, and so you will notice that all resistors that use these color markings are only accurate to 2 significant digits. Okay, so if you look at the example on the right, on the lower right hand, A is equal to red, B is equal to violet or purple, okay, and C is equal to green. Okay, so that is 2.7 times 10 to, or 27 times 10 to the 5th, or 2.7 mega ohms. D, being gold, means it's plus or minus 5%. If D was silver, it'd be plus or minus 10%. So the standard color code, and by the way, this really does need to be in your binder, is black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver. Now, gold and silver or none are always that fourth or that D marking, okay? And it's how accurate is it plus or minus 5%, plus or minus 10%, plus or minus 20%, okay? You will also find that generally speaking, you know, that if they use generally speaking, it's going to be gold, silver, or none. However, in some cases, they will use one of the other colors like brown or red or green as tolerance markings for very, very high tolerance or very, very low tolerance resistors. Okay. Now, many resistors, when you look at a resistor, and if this is a little bit like the capacitance problems, it should, but if you look at the resistance, they're usually defined by the material, the surface area, and the length of the material. Okay, so R is equal to rho times L divided by A. Okay, where rho is the resistivity of the medium. So you'll have very low resistance for conductors like copper, very high resistance for insulators. And then what they'll often use they'll use semiconductors, which have sort of medium resistance for actually making resistors. L is the length and A is the area. So a common use of this formula, which should be in your binder as well, is I will say I have 2 kilometers of copper wire of a certain gauge. Okay, so the 2 kilometers is the L. The certain gauge tells me what the A is because different gauges have different surface areas, and rho is the resistivity, and they'll either give you the resistivity or they'll expect you to have it in your binder. So just remember, resistance increases for longer lengths, smaller or thinner wires with less cross section, higher temperature, and less conductive material. And then if you want to decrease your resistance, shorter lengths, larger area cross section, lower temperature, and more conductive material. So let's think about what are some of the resistivities of common materials. Silver is 1.59 times 10 to the minus 8 ohm meters. Holy smokes, that is really, really low. And you'll notice that that is it's very close to copper, but it is much more conductive than aluminum. Okay, aluminum is still a good conductor, but aluminum is going to heat up more because it's going to have more resistance. A lot of your semiconductors, you're talking about gallium arsenide, germanium, silicon. Okay, those are like 10 to the 8th, 10 to the minus 1, 10 to the 2 when you're looking at the resistivities. So you're talking about anywhere from 7 to 16 orders of magnitude more. But then when you get to the insulators, now you're talking 10 to the 17th, 10 to the 21st, 10 to the 23rd, 10 to the 25th. So now you're talking about just a ridiculous amount of resistance. Now, there are standard resistor types. And so if you go out and you buy resistors from like Radio Shack online or something like that, there's basically 12 standard resistor types. 10, 12, 15, 18, 22, 27, 33, 39, 47, 56, 68, and 82. Okay, so these are the 12 most common resistors, okay? And they're usually, they're the most common resistors for 10% resistors, okay? They're based upon their tolerance and the geometric progression. And when we get into, like, if I want to make a 5 ohm resistor out of this, I would take 2 10 ohm resistors, put them in parallel. Okay, pretty simple. All right. And what you'll find is that it's real easy for you to create any resistance you want using these resistors, okay, in some sort of combination. And that's why they pick these types. So here's a 100 kilo ohm resistor, and you'll notice it goes brown, black, yellow, okay? And I look at the fourth band, it's silver, so it is plus or minus 10%. Okay, now in a class quiz, let's look at the resistor values for the following. Now you'll notice that some of these, like the ones on the top row on the left hand side, are brown, black, black, and the other one's brown, black, black. So those two, actually the resistor amounts should be exactly the same, but you'll also notice that also one has a silver, one has a gold, so they have different tolerances. And then the rest of them, I think, all have silver tolerances. But you'll notice that even when they use the same colors, if the colors are in different orders, remember it's an order of magnitude problem, so they will be different. So I would like for you to again go to scioli.org, grab another sample test, practice again, give yourself only 40 minutes, okay? Use your binder, use your calculator. Make sure you put your name and team at the top of each page, okay? Tackle the easy problems first, then the tough ones that you know how to tackle, and then the tough ones you have to guess on. And always check your answers if you have time. Make sure that you go through the binder checklist to make sure that your binder has all the materials that you need, that you can easily find them. Do your own binder checks to make sure you can find all the equations and all the materials and all the history and all the ways to solve problems that you need to find. For your homework, continue to work on your binder. Now I want you to do level 6 combination, level 6 multi-source, and level 10 resistors. Yes, it will actually go out and it will give you a whole bunch of different resistors, and every time it's a different set of resistors to see if you can properly identify the resistors. Thank you so much, and this completes